Hello, my dear students. In this video module, I am going to present in front of you the basic concepts related to the topic calendars. We will be talking about the concept related to odd days, and also we will talk about the leap year concept and the non-leap year concept. Let's get going. Consider today it's Wednesday. Okay. So my question is, what will be 0 days from today? 0 days from today, it's as good as today itself. So 0 days from today, I can say it will be Wednesday. What about 1 day from today? 1 day from today, it is Wednesday plus 1. I can say 1 day from today, it is Thursday. 2 days from today, today being Wednesday, 2 days from today, Wednesday plus 2. So Thursday, Friday. Okay. What about 3 days from today? Wednesday plus 3. Thursday, Friday, Saturday. So in this way, when I consider 4 days from today, it will happen on a Sunday. 5 days from today, it will happen on a Monday. 6 days from today, it will happen on a Tuesday. And 7 days from today, once again, it will be happening on a Wednesday, right? So can I not say 7 days from today, it is as good as 0 days from today? Observe this closely. Okay. So continuing with this logic, can I not say 8 days from today, it is as good as 1 day from today? So 8 days from today, it will happen on a Thursday. Likewise, 9 days from today, it will be happening on a Friday. 9 days from today, it is as good as 2 days from today. So it will fall on a Friday. Similarly, 10 days from today, it is as good as 3 days from today. It will fall on a Saturday. 11 days from today, it is as good as 4 days from today. It will fall on a Sunday. 12 days from today, it will fall on a Monday. It is as good as 5 days from today. Similarly, 13 days from today, it is as good as 6 days from today, and it will fall on a Tuesday. Now observe closely. 14 days from today, it is as good as 7 days from today. It is again as good as 0 days from today, that is today itself. Now, suppose I am considering n days from today. I will be dividing that n with 7, and then I will find out what is the remainder. This is the modulo operation. Okay, modulo 7. So n divided by 7, you find out what is the remainder. That remainder, what you are getting, it is nothing but the number of odd days. Okay. So when I considered 14 days from today, I divided that 14 with 7. I got the remainder here as 0. So I will say 14 days from today, it is as good as 0 days from today, which means 14 days from today will be today itself. We are considering today being Wednesday. So 14 days from today will be again falling on a Wednesday. In the same way, let us consider what will be 50 days from today. So 50, I am going to divide it with 7. I know that the remainder, it is equal to 1 in this case. 50 modulo 7, it is equal to 1, right? So the remainder, it is equal to 1. So I will say that 50 days from today, it is as good as 1 day from today, Wednesday plus 1. I can say that it will fall on a Thursday. Clear? In the same way, suppose I am considering 73 days from today. Let me find out what is 73 modulo 7. So 73 by 7 when I do, I will get the remainder here as 3. So 73 days from today, it is as good as 3 days from today. And I can see that 73 days from today, it will fall on a Saturday. So likewise, we will be considering the number of days, and then we will find out what will be the remainder that you get when you divide the number of days with 7. And that corresponds to the remainder what you are getting, it corresponds to the number of odd days. So please note this concept. Now, let us talk about the number of days in a month. We all know that January, it has got 31 days. February, depending upon whether the year it is a leap year or a non-leap year, the number of days will change. For a non-leap year, February will have 28 days. And for a leap year, we can see that February will have 29 days. Okay. Now, March will have 31 days, April 30, May has got 31 days, June has got 30, July 31 days, August also 31 days, September month has got 30 days, October 31 days, November 30 days, and December 31 days. I'm sure that you all will be familiar with the right hand fist rule, right? Right hand fist rule. By using the right hand fist, you can remember the number of days in a month. If you have got any doubt how to find out the number of days in a month with the help of the right hand fist, please let me know in the classroom. I shall explain to you. So you should be having a clear idea the number of days there in a given month, and I have presented it here. Please note February alone, it will be 28 or 29 days, depending upon whether it is a non-leap year or leap year, respectively. Okay, now let us consider how to find whether a given year it's a leap year or not. If it's a century year, then if it is divisible by 400, then understand that the given year it is a leap year. Okay, else if it's not a century year, you check whether that given number, that year, it is divisible by 4. Okay. So, for a year to be a leap year, if it is a century year, then check whether it is divisible by 400. Else, you check whether it is divisible by 4. Okay. So, let us take some examples. 2000. It's a century year. 2000, it is divisible by 400. So 2000, it's a leap year. Now consider 2100. 2100, it is also a century year. But 2100, it is not divisible by 400. So 2100, it's a non-leap year. Similarly, 2200, it's a non-leap year. 2300, it's also a non-leap year. Okay. Now, 2400, let us consider. 2400, it's a century year. And 2400, it is divisible by 400. So 2400, it will be a leap year. Similarly, 2800, 3200, 3600, 4000, so on and so forth. All these century years will be leap years. Okay. In the same way, let us consider 2024. 2024, it is not a century year. But 2024, that number, it is divisible by 4. So I can say that 2024, it's a leap year. Similarly, 2028, 2032, and if we are traveling backwards, 2020, okay, 2016, like that, when we consider all these years, they are not century years, but they all are divisible by 4. So they all are leap years. Okay. So keep this aspect in mind to check whether a given year it is a leap year or not. If it is not a leap year, then we consider it as a non-leap year. And in a leap year, February will be having 29 days, and also in a leap year, the total number of days associated, it will be 366. Okay. So a leap year has got 366 days altogether, which means a leap year, it is associated with 2 odd days. Okay. When I divide this 366 with 7, I will be getting the remainder. It is equal to 2. So I can say that a leap year, it is associated with 2 odd days. Similarly, When I am considering a non-leap year, February will be having only 28 days. And also the total number of days under consideration, it will be 365 days for a non-leap year. And a non-leap year, it is associated with one odd day. When I divide 365 with 7, I will be getting the remainder here as 1. So I will say that a non-leap year, it is associated with one odd day. Okay. So I shall just summarize the proceedings so far. Leap year, February has got 29 days. It has got altogether 366 days. It is associated with two odd days. Similarly, for a non-leap year, you can see that February will have 28 days. The total number of days, it will be 365, and it is associated with one odd day. Okay. Now, let us do one problem here. 11th August 1985. It is said that it happened on a Sunday. It's a condition-based question. Okay. If 11th August 1985, it happened on a Sunday, then which day of the week was 13th August 1986? So you can see that the journey, it starts from 11th August 1985. 11th August 1985 to, let us find out what is happening till 11th August 1986. Both these years under consideration, they are non-leap years, 365 days. So I can say that from 11th August 1985 to 11th August 1986, it corresponds to one odd day. Now, we have to travel till 13th August 1986, right? So we have to consider 12th August and also we have to consider 13th August. So we have to consider 2 more days. So we will add 2 to this. Okay. So altogether, we can say from 11th August 1985 to 11th August 1986, it is one odd day, it being a non-leap year. Now from 11th to 12th, it's one day. 12 to 13, it's another one day. So 1 plus 1, 2 more days we will add. So 2 plus 1, I will say it is associated with 3 odd days. All right. Now, it all started from 11th August 1985. It's said to be on a Sunday. So we will consider Sunday plus 3, Monday, Tuesday, Wednesday. So I can thus say that 13th August 1986, it will be happening on a Wednesday. Option D will be the answer for our question. Using this logic, you find out what is the total number of days that you are considering. Then you find what is that n modulo 7. And then, depending upon the situation, whether you are traveling forward or backward, you do plus or minus, and then you arrive at the day associated with that destination date. Okay, let's do one more problem. It's given 8th February 1995. It's happening on a Wednesday. So let me mark that date here, 8th Feb 1995. Condition is given, okay, if it is happening on a Wednesday, the question is 8th February 1994. So you have to travel backwards there. Okay. So kindly note you are traveling backwards. So I shall just redraw this. Let's consider 8th February 1995. So I shall just mark it here. 8th Feb 1995. Condition wise, it's said to be on a Wednesday. You are asked to find what day of the week 8th February 1994 this was. Okay, so this is the question. So you're traveling backwards. So from 1995, 8th February 1995 to 8th February 1994, when you are considering, you are again dealing with 365 days. It's just one odd day. The total number of days, it is 365. So 365 days you are considering, and it is just one odd day. 1994 that you are considering it's a non-leap year. Okay, so 365 days. So it is associated with one odd day. But here, since you are traveling backwards, you should be doing Wednesday minus 1. And I can see that the correct answer for this question, it will be Tuesday. So 8th February 1994, it happened on a Tuesday based on the condition given. All right. So like this, you will be using this logic for solving problems. Now, let us consider the January 1st, that is the New Year day, associated with several years starting from 2000. You can take the calendar and you can verify all these details very much. 2000, January 1, it happened on a Saturday. Okay. So when we are traveling from 2000 January 1 to 2001 January 1, we are considering 366 days. That is 2 odd days. So that's what you see here. Saturday plus 2, Sunday, Monday, it comes. So you are considering Saturday plus 2, it is Sunday, Monday. 2001 January 1, it happened on a Monday. Now, when you are traveling from 2001 January 1 to 2002 January 1, you are just traveling through the non-leap year logic. Okay, 365 days. So it is associated with one odd day. So Monday plus 1. You can see that 2002 January 1, it happened on a Tuesday. Similarly, 2002 January 1 to 2003 January 1, when you are considering, again, it's a non-leap year logic. So plus 1. Tuesday plus 1, it's happening on a Wednesday. Now, please observe closely. 2003 January 1 to 2004 January 1. Okay, so 2003 January 1 to 2004 January 1, again, it is associated with 365 days only. Okay, so there is again one odd day, Wednesday plus 1. You can see that 2004 January 1, it happens on a Thursday. Now, 2004 January 1 to 2005 January 1, when you are considering, there you are crossing the month of February, which has got 29 days. Got it? So it is a leap year logic. So 366 days, 2004 January 1 to 2005 January 1, it is 366 days. So it is 2 odd days. So that's why Thursday plus 2, Friday, Saturday, it comes. And the same logic, it continues. It follows like plus 2, plus 1, plus 1, plus 1, plus 2. You can say Thursday, Friday, Saturday. So you can say plus 1, plus 1, plus 1, plus 1. Like that, here it will be plus 2. Okay, like that it goes. So look at this, plus 2, plus 1, plus 1, plus 1, plus 2, plus 1, plus 1, plus 1. Again, plus 2. You can see that Monday, here, plus 1 when you are doing, it comes here as Tuesday, because 2007 January 1 to 2008 January 1, it is 365 days only. So you are doing Monday plus 1, Tuesday. But again, here you have to go for plus 2, because 2008 January 1 to 2009 January 1, when you are considering, you are dealing with 366 days, because you are crossing the month of February in 2008, which has got 29 days. So it is plus 2, and then Tuesday plus 2, Wednesday, Thursday. And this logic continues. So just remember this cycle: plus 2, plus 1, plus 1, plus 1, plus 2, plus 1, plus 1, plus 1. So it is plus 2, plus 1, plus 1, plus 1. Again, it will be plus 2, plus 1, and so on and so forth. If you consider 2025 January 1, it's going to happen on a Wednesday. Okay. So again, you can say that this is plus 2, plus 1, plus 1, plus 1. That logic actually continues. Saturday plus 2, Sunday, Monday plus 1, plus 1, plus 1. And this logic actually continues. And you will find it very useful. This table, you will find it very useful and handy for solving many questions. Okay, so you may take a screenshot of the same and keep it for your reference. Now, there is a concept related to the calendar reusability that we will consider. Every leap year in general repeats itself in 28 years, which means 2000 calendar you can use it again after 28 years. You can use it again in 2028. If you remember, we saw 2000 January 1, it happened on a Saturday. So 2000 January 1, it happened on a Saturday. 2028, again a leap year, January 1, it will be happening on a Saturday. We shall validate this. Okay. Similarly, 2000, say 16, I am considering. Okay. 2016, I am considering. 2016, it's a leap year. The 2016 calendar can be used again after 28 years. Okay, so 2016 plus 28. That will be 2000. How much it will be? 2016 plus 28. I can say 2044. We can validate this. Okay, so please have a look at 2016. 2016 leap year Friday. 2044 leap year Friday. See, we can use that calendar. 2000 we consider 2000 Saturday. 2028 January 1, it also falls on a Saturday. So that's the logic. Okay. So every leap year in general repeat itself after 28 years. Now consider if the year is in the format leap year plus 1. For example, let us consider 2025. 2025 is in the format leap year plus 1. It is 2024 plus 1. It is 2025. Okay, so 2025 is in the format leap year plus 1. The 2025 calendar can be reused again after 6 years. You know that 2025 plus 6, it is equal to 2031. We just consider 2025 January 1, it will be happening on a Wednesday. So based on the prediction what I have made, 2025 calendar can be reused again after 6 years. That's in 2031. So 2031 January 1 should also happen on a Wednesday. Okay, let us refer the table here. 2025, you can see that January 1, it's on a Wednesday, plus 6. 2031, you can say January 1, it's again happening on a Wednesday. So 2025 calendar can be reused again in 2031. So using this kind of a logic, when we are considering if the year is in the format leap year plus 2, or if it is in the format leap year plus 3, it can be used again after 11 years. For example, let us consider 2023 calendar. You know 2023 is 2020 plus 3. It is in the leap year plus 3 format. Okay, so 2023 calendar can be used again after 11 years. We can reuse it again in 2034. Okay, we know that 2023 calendar can be used again in 2034. Let us verify this. 2023, you can see that January 1, it happened on a Sunday, right? So plus 11, 2034. We can see that 2034, January 1, this is also happening on a Sunday. Okay, so 2023 and 2034, January 1, it is happening on a Sunday. So the calendar can be reused. Okay, so I have proved the following point here, the calendar reusability part. In general, leap year repeats itself in every 28 years. Leap year plus 1, 6 years. Leap year plus 2, 11 years. And leap year plus 3 also 11 years. That's the reusability, that cycle associated with it. Okay, so make a note of this point presented. Now, let us consider some interesting parts related to leap years. In a leap year, please note January and July, they are identical twins. What is that identical twins? It means both these months, January has got 31 days, July also has got 31 days. And both these months, they start with the same day. And this is applicable for any leap year for that matter. Okay, in a leap year, similarly, January, April, and July, they start with the same day. I can't call them as identical twins because January has got 31 days and April has got only 30 days. So I cannot call them as identical twins, but they start with the same day. And in the same way, in a leap year, February and August, they start with the same day. I cannot call them as identical twins because in a leap year, February has got 29 days and August, it has got 31 days. So they cannot be considered as identical twins, but both these months, they start with the same day. And similarly, in a leap year, March and November, they also start with the same day. March has got 31 days, November has got only 30 days, so they are not identical twins. But still, in a leap year, March and November, they start with the same day. You can take any leap year calendar and then you can validate all these findings. And knowing these 4 points will help you a lot in solving problems. All right, let us verify this. 2024. Okay, let us consider 2024 calendar. 2024, you can see that it is a leap year. 2024, it's a leap year. All right. So as indicated, January and July, they are identical twins. We can see that January, it starts on a Monday. July also, it starts on a Monday. January and July, they are identical twins. Okay, both have got 31 days. So identical twins. Now, in the same way, we can see that January, April, July, they start with the same day. When you verify this, you can say January starts on a Monday. April also, it starts on a Monday. And July also, it starts on a Monday. They all start on the same day. Okay. In the same way, in the case of a leap year, February and August, they start with the same day, the third point. Observe February. February 1, Thursday. August 1 also Thursday. So February and August, they start on the same day. And in the same way, we can see that March and November, the fourth point what I have mentioned, March and November, they start with the same day. Observe March, the first is on a Friday. And also we can say November 1st, it's also happening on a Friday. March and November, they start on the same day. Okay, so we can validate all these findings here. So please make a note of these 4 points separately. Now, similarly, for a non-leap year, a similar observation can be made. In a non-leap year, January and October can be considered as identical twins. Both January, it has got 31 days. October also has got 31 days. And they start with the same day in a non-leap year. And in a non-leap year, February and March, they start with the same day. And in a non-leap year, April and July also, they start with the same day. Let's verify all these things. I'm not going too far. I'm just taking the next year calendar, 2025. It's a non-leap year, right? So as said, January and October, they are identical twins. You can see that they start on the same day, Wednesday. And both January and October, both have got 31 days. They are identical twins. Okay. In the same way, in a non-leap year, April, July, they start with the same day. So you can say April here, it starts on Tuesday. July also, it starts on Tuesday. April and July, they're not identical twins, but April and July, they start the same day in a non-leap year, April and July. Okay, so make a note of these points. In the similar way, when we considered in a non-leap year, February and March also, they start in the same day. Okay, so let's verify this. February, it started on a Saturday. March also, it started on a Saturday in a non-leap year. So in a non-leap year, February and March, they starts on the same day. Okay, so these points, the 3 points what I have mentioned here, make a note of it separately and you will be finding it very useful for solving problems the moment you identify whether a given year it's a leap year or a non-leap year. Okay, now let's also consider another commonly asked question. The last day of a century, it cannot fall on. 4 options will be given. So make a note of this. Last day of a century, it cannot fall on a Tuesday. It cannot fall on a Thursday. It cannot fall on a Saturday as well. So last day of a century, it cannot fall on Tuesday, Thursday, Saturday. I use the code word TTSAT for remembering this. Okay, T for Tuesday, T for Thursday, and SAT, SAT for Saturday. So last day of a century, it cannot fall on Tuesday, Thursday, Saturday. All other days are possible, but it cannot happen on Tuesday, Thursday, Saturday. It's a commonly asked question for many competitive exams. So that's why I have presented it separately. So with the help of all these logic that I have covered in this video module, now you are confident enough to attempt the questions from the topic that is calendars. Always keep your curiosity alive and please do solve more problems from the topic on calendars and enrich your knowledge. Thank you very much for watching this video module.